Hello, this is the lesson over properties of mathematics. I'm going to start this lesson by showing you examples of the properties, not proofs. Okay, so the first property is the associative property. And so here is an example. An example would be 7 plus 5 plus 5. And I want to show that this equals 7 plus parentheses 5 plus 5. So I want to make sure that both of these two sides of the equal sign equal each other. So 7 plus 5 is 12 plus 5. 12 plus 5 is 17. And I want to show that that equals 7 plus 5 plus 5 is 10, and 7 plus 10 is 17. Since those two equal, that shows that if I group the first two, and then add to the third, then I get 17. And that's the same thing as adding the last two and adding it to the first one. That is an example of the associative property, not a proof. Okay? The second, and that is the associative property of addition. Now let's show an example of the associative property of multiplication. Now, notice that I'm using EX for example. Typically, when I write my notes, I'll put example, EX equals example at the top of the page. And I'll do that every time I introduce a new abbreviation for a word. Now, I love doing abbreviations. When I was in 7th grade, I guess it was 8th grade, I had a biological science teacher. It wasn't biology at that time, but it was biological sciences teacher who sat on her desk and took notes, and you had to copy. She had 3-subject college rule notebook, and you had to copy word for word what she said. And at the end of every test, you had to turn in your notebook, and it had to copy verbatim what hers was. And so I learned to take notes like hers. So for the next one, we're going to have 4 times 6 parentheses times 5, and that has to equal 4 times parentheses around 6 times 5. So 4 times 6 is 24 times 5. And now I'm going to go over to the side and write that vertically because that makes more sense to me. So 4 times 5 is 20, and 2 times 5 is 10, plus the 2 gives us 12. So the left side is 120. Now on the right side, I have 4 times 6 times 5 is 30, and to do 30 times 4, 3 times 4 is 12, and then I just tack on the 0. All right? And so the right side is easier to do because I don't have to write it vertically. Okay? So up in addition, the right side was easier to do. So in both of these examples, I see that sometimes using the associative to regroup things, I can make my problems easier, and that can help me to work the problems. Okay, now let's go on to the next property, which is the commutative property for addition and multiplication. And an example of this, an example for addition would be 3 plus 2 equals 2 plus 3. Well, 3 plus 2 is 5, and 2 plus 3 is 5. What I like to think about this equal sign right here as a mirror. And all it's doing is it's giving us a mirror image of the problem. And so all we're doing with commutative property is we're flipping. So notice that these two are the same thing on each side. Okay? And the same thing for the commutative property of multiplication. It allows us to say 3 times 2 equals 2 times 3. 3 times 2 is 6. 2 times 3 is 6. Again, we have a mirror of the same thing on each side. Okay, so let's go down. The next property is the most used and the most misused property. And the way I say used and misused is when we go to doing it this way, most people tend to forget to go to the second term. This is the distributing. You're distributing things to each term. The property we're talking about now is the distributive property. So what you're going to do here is you want to be fair to everybody. I like to call this the fairness property. And that's just me and my little thing about this. So here you're going to think about this as you want to be fair to the entire class. So you're going to be fair, passing out 10 points. So if you want to give 10 points to your class or 10 points to everybody, then you want to be fair to everybody, not just to the first person on the roll. Again, factoring is going the other direction. So if you're going this way and you made a mistake, and so you want to take off a question. So here I'm using QUEST. That equals question. Then if you want to take off a question, you don't want to just take it off for the first person on the roll or for the last person on the roll. You want to take it off for everybody. Take off for everyone. Okay, so you want to be fair to everyone. This is the fairness property. Okay, so now the next few properties that we're going to talk about are the little properties that we all know that we have, which is the identity property, and it actually has two little things. So we have the identity property of addition, which means that we have a 0, but that's also the same thing as the addition property of 0. And so that means that we have a 0 for addition, and that identity property for addition is 0. So the identity for addition is 0, and the addition property for addition is 0. So the 0 property and identity are the same thing. The identity property for multiplication is 1. So the identity for multiplication is 1. The additive inverse is negative a or negative whatever you have. The multiplication inverse is the reciprocal, is 1 over whatever you have. And the multiplication property of 0 is that if you multiply by 0, you get 0. All right? And most of those we know, we just don't call them by their name. And that's one of the things that I want to stress in this thing, is that we're wanting to learn to call things by their name. There's a great line in The Lord of the Rings that a name has power. And one of the things that in teaching high school and middle school, and y'all are going to be mostly middle school teachers, is that you want to realize that names, giving things name, gives that item power. Okay, solving equations. The biggest thing here, and I'm going to actually move this up a little bit more so that we can get all of these things, all of these definitions on one page, or most of them, is the biggest thing here is that what we want to do is we want to realize that what you do to one side so what you do to one side, you must do to the other. You have to keep the equation balanced. I can't spell. Okay, and right now I'm just going to go over here and tell you that EQN will forever be equation. Okay? One of the things that my 8th grade bioscience teacher taught us, she taught us abbreviations. So forever equation is EQN, energy is NRG, function is FCN. Those are ones that I have learned since I was in 8th grade, and they have ever been that way. There's a few others, and we'll come across them as the course goes on. And they're ones I've used since I was in 8th grade, and that's just the way I always abbreviate things. So, if I add something to one side, I have to add it to the other. If I subtract something from one side, I have to subtract it to the other. If I multiply, I have to do it to the same, and if I divide, I have to do it to the same. Most of you have done this and seen this, but this section is review, this chapter, this week, this lesson is review. Again, I'm trying to put names to things so that you can know what the names are. All right, the next set of information that we're going to talk about here are reflexive property, symmetric property, and transitive property. These three properties are mostly used, and I'm not going to say all the time, but they are mostly used in geometry. I'm talking about them here because they are sometimes used in other things, and they are properties of mathematics, and they are covered in the properties of math, and I wanted to be thorough. But they are mostly used in geometry. All of you will end up taking 4370. So I wanted you to see these before you go to 4370 so that you would know what to expect. The next thing I have given you is a table of all the properties except for the equality properties and the reflexive, symmetric, and transitive properties. All right, now let's get into seeing how these are used into actual examples. Okay, explain the transitive property. So the easiest way that I have is I have set up some ideas of some logic statements. So, here we go. Sorry, I had to take a sip of my coffee so that my voice doesn't keep cracking. Excuse me. If I let A, if I let A be the statement, the corner of this paper okay, and I let B equal the corner of the room. Okay, now I'm going to tell you that A equals B. They're both 90 degrees, A equals B. Then I'm going to tell you that C equals 90-degree angle. Then I know that B equals C because it's 90-degree angle. So then, this symbol right here means then. Mathematically, it means then. Forever, it means then. I can write it to a Russian mathematician and they know it means then. Then I know that by the transitive property, or because, that should be universal for because the transitive property so this is transitive property. What? I'm off the page. Property. We know that A equals C. That's how the transitive property works. I say A equals B. I assign A and B some values. I say B equals C, assigning B and C some values. Then I say that by the transitive property, I know that because A equals B and B equals C, then I know that A equals C. All right. Which equation shows the commutative property? What is the commutative property? The commutative property remember I described as a mirror, is the mirror. So which of these is the mirror? Which one, if I put a mirror on it, would show me the reflection about it? Well, it's not this one. It's not this one. It's not this one, so it has to be D. So the answer, so D shows that 5 times 6 equals 6 times 5 is a reflection of itself. LF. Okay. All right. Which property represents the following statement? A equals B, then A plus C equals B plus C. Well, that would be the addition of equality, correct? Okay. Identify the property that states that adding 0 to any number leaves it unchanged. Well, isn't that the identity of addition? Identity of addition says that if we add 0 to any number, we get the number we started with. I cannot write today. In other words, A plus 0 equals 0 plus A equals A. And right here I stated it as the commutative property just to be complete in my statement. All right. So, identify the property that states if you subtract the same number from both sides of the equation is still true. How about the subtraction property of equality? Subtraction property of equality. All right. And now we have two more. Identify the property that states when three or more numbers are added, the sum changes regardless of the grouping of the add-ins. Okay, directions. So this example for 6 is associative property. All right, and then directions for 7 and 8 is use the associative property and commutative property to reorder the operations into groups of 10 and add. Explain which property you're using. Okay, first I have a standing rule that says you don't add an equal sign, but because we're going to be using the associative property and commutative property, I am going to add in equal signs. So first thing I'm going to do is I'm going to add an equal sign, and I'm going to reverse the 5 and 4. So I have 6 plus 4 plus 5, and reversing those two was the commutative property. All right. Then the next thing I'm going to do is I'm going to group 6 plus 4 plus 5, and that's the associative property. So 6 plus 4 is 10 plus 5, and I added. And 10 plus 5 is 15. And I added again. Okay, for number 8, I'm going to reverse 8 and 3. So that's 8 plus 3 plus 7, and that's the commutative property. And I'm going to group 3 plus 7, and that's the associative property. And so that's 8 plus 3, the parentheses is 10, and then I have 18. Alrighty? And I think we're done with this. So if you have any questions, please email me, and thank you.